All right, so getting into some good stuff today. That last unit we just tested on, and this unit we're getting into the really good stuff. The first two units is pretty much just learning stuff that allows us to do what we're doing now. So those are kind of boring, but now we're getting into the really good stuff to where you're actually applying what you learned. All right, so today we're going to figure out intervals of when a function is increasing or decreasing just by looking at the graph of the derivative. Okay? So that, before we get started, we want to go back to our f. Actually, when we did this, we didn't do f prime and f double prime. What did we do instead? When we made our chart. Position, velocity, and acceleration. Okay? But the same holds true for f prime, and f double prime, because if I have position here and I take the derivative, what do I get? I get velocity, and if I take the derivative of velocity, what do I get? Acceleration. So all three things apply to f prime, and f double prime. Okay, so somebody help me fill out this chart. What are some things we know about this chart? Raise your hand for me. I know it's the Monday after Thanksgiving, but we got to get rolling. We got some good stuff to do between now and the 20th.
To the right, then velocity is increasing. Right.
You're saying moving to the right and increasing are the same thing. So you can't say something is moving to the right because something else is increasing. You have to say something's moving to the right because something else is positive.
Yeah.
Okay. So what's positive?
Velocity is positive.
Velocity, but in this case I don't have velocity up here. What do I have? I have f prime, and f double prime. So what do I want to know is positive? What? F prime is positive. If f prime is positive, then that means the function above it is increasing. Okay, the other option for f prime is negative, which means the function above it is decreasing. All right, what else can I do? Alexis?
If f double prime is positive or negative, then f prime is increasing.
Okay, very good. So today our main focus is going to be on that right there. Okay, and what did I say we're going to have the graph of? We're going to have the graph of the derivative. Okay, so that means I'm looking here to talk about here. Okay, so we're going to change what this says because I don't like what it says. All right, so on the first one it just says that we're dealing with f, okay, but I want you to ignore that. I want you to treat this as f prime. It's not going to let me do it. All right, so this says we're looking at f. We're going to treat that as f prime of x. Okay, and we're going to do the same thing here. Instead of that, we're going to say we're looking at f prime of x. Okay. So, given a graph of f prime, we want to determine when f is increasing. So, given a graph of f prime, I want to determine when f is increasing. So I want to know when is f increasing, which means I need to be looking for what?
All points in which is positive.
I want to be looking for when f prime is positive. Okay? And if I'm looking at a graph and I want to know when that function is positive, that means it's got to be where? Above the x-axis. So that means I'm interested in this section right here, and I'm interested in that section right there. Okay? So what's that first interval? B to D. Okay. And then what?
F to G.
And then F to G. Everybody good with that? Okay. Now, we always follow something up by doing what? Justifying, good. So we're going to say because what? How did you know it? How did you know those were increasing and decreasing?
F prime is positive.
Because F prime is positive. Because F prime is positive. How we feel about that? Give me a thumbs up if you're okay with that. Good. All right. Part B says write any intervals in which the function f is decreasing. So now what am I looking for?
Anytime it's negative.
When we're below the x-axis, so we're going to be below the x-axis here and there. So what's my first interval? A to B. And my second interval? D to F. And my justification?
F prime is negative.
Because F prime is negative. Feel good about it? All right. Do number 2. You can use a partner if you need it, but do number 2.
Yeah, I've got that thing for like 5 years.
The pencil?
That,
Or the iPad? Both of them?
both of them.
I lost one.
And I like never use it. I'm like, I need to like.
All right, Ariel. Intervals in which we're increasing. Say it again. B to E.
D.
B to D. Another one.
F to H.
F to H. Because
F prime is
how many agree with that? You're saying no? Why are you saying no, Gavin? Right here?
oh, D is.
There's G prime. There you go. Good. Good catch. Good job, Ariel. All right. Bethany, give me B. Intervals when we're decreasing.
A, B, and D, F.
A, B, and D to F. Because
G prime is negative.
like it? Very nice. Easy stuff.
Yeah.
Trevor, you should be nice. You should be nice and refreshed. You should be, well rested, not sleepy. All right. Do this one for me too. You can handle this one too. Couple minutes to do this. All right, Michaela, what do you got for increasing?
A to B and D to H. Because H prime is positive.
How many of you like that? Everybody's good with it? Xavier, you're good with it?
I think so.
You think so? Nancy, you're shaking your head no?
No,
I don't-
because I said at F, it's technically 0, so it's not positive or
Okay.
negative.
So what adjustment did you make?
I just separated DF and then H.
Everybody see what she's saying? Because in order to be increasing, my function has to be positive. And at F, what is my function? 0, which is not positive. So Trevor, that means I've got to split it up. Okay? All right, Deborah, what'd you get for B?
I got B to D and H to I.
B to D and H to I.
Because H prime is negative.
Because H prime is negative. So B to D and H to I because H prime is negative. Like it? Okay. All right. Fill out that check for understanding for me real quick. You can't do it on there. You got to write it down. Tomorrow, I'll have something for you that you can fill out on the computer. But today, you're just using it. I was like, where's my stinking phone? It's recording. All right, Wilson, what do you got for the first one? When looking at the graph of a function, how can you tell whether the value of that function is positive or negative?
If it's above the x-axis,
Or, because it says positive or negative,
oh, or below it.
or below it. So if it's above the x-axis, we're positive. Below the x-axis, we're negative. What condition on the derivative of a function would guarantee that the original function is increasing on a given interval? Jessica, what do you think?
If the derivative is positive.
If the derivative is positive, very good. What condition on the derivative of a function would guarantee that the original function is decreasing on an interval? Gavin? If the derivative is negative. Very good. All right, now let's see what we got here. Let's see who's on top of it today. The following is a graph of two functions defined on the interval from a to I. One function is g of x, whose graph is a solid curve. The other function is h of x, whose graph is a dashed curve. One of these functions is the derivative of the other. That is, either g of x is equal to h prime or h of x is equal to g prime. Decide which of these alternatives is correct and support your assertion with as many specific facts regarding the features of the graph as you can. So one of these functions is the original function, and one of these functions is the derivative function. So take a second to look at it and figure out which one's which, and then be able to support your claim. So I'm going to give you a couple minutes to look at it. Alright. Anybody got any ideas? Nancy?
I said that h of x is g prime of x.
You said that h of x is g prime of x. So that means the dashed one is the derivative? That's what you're telling me? Alright, so Nancy says the dashed one is the derivative. Alright. Anybody else feel strongly about that? And agree with her? Alright, Emily? Why do you think the dashed one is the derivative? Give me a reason why.
As the dash one is positive, the not dash one is increasing.
Okay, so as the dashed one is positive, the not dashed one, the solid one, is, what did you say, increasing?
Increasing.
Alright, so give me an example of that.
C to F.
C to F,
Dash one is positive.
dashed one's positive,
The
which
solid one's increasing.
which means the solid one's increasing. Alright, give me another example.
A to B, it's the dash one is increasing, but
You're confusing yourself.
yeah.
Alright, go back and tell me, what did you tell me about C to F?
C to F.
The dashed one was what?
Positive.
Alright, so now think about that. Tell me where the dashed one's positive or negative and what that means about the other one.
From B to E,
From B to E,
the solid one is increasing, and then the dash one is positive, but not.
alright, you were on it on your first example and now you're struggling. Xavier, help her out.
A to C, the dash one is negative.
Okay, which means the solid one should be decreasing. Okay, so let's kind of highlight that. So the dashed one is what there? Negative, which means the other one has to be what? Decreasing. Okay, so I'm negative and I'm decreasing. Does that match? Yes. Okay, then the dashed one is, what is it there? Positive, which means the other one needs to be increasing to there. Is it? Yes. Then the dashed one is still positive, so that means the other one still has to be increasing. Okay. Then the dashed one is negative, which means the other one has to be decreasing. There it is. Okay. Very good. Now, I want us to notice something else about this graph. All right, so we said the dashed one is my derivative. Okay, the dashed one is my derivative. Let's talk about something that I think we've talked about before, or we may not have. Have we talked about critical points yet? Yes, we did? Okay. Remind me what we said about critical points. Are you sure we've talked about them?
I don't think we did.
Kind of, yeah. All right, critical points. two things are happening when you have a critical point. The derivative is either 0 or the derivative is undefined. Write that down. Critical points occur when the derivative is what? Is 0, and I said or what? Or undefined. And critical points occur when the derivative is 0 or undefined. Critical points occur when the derivative is 0 or undefined. Now, I know we've talked about this next word. Relative extrema. What are we talking about with relative extrema? It's been a little bit, but I am totally positive we talked about that. Alexis?
I'll just take it and guess when it's the maximum or minimum.
Maximum or minimum, okay. And we said maximums occur, what's going on with my graph if I have a maximum? Right, what did we say that was? How did we describe it? A hill, and minimums occur at valleys, okay? Okay, relative extrema can only occur at critical points. Okay, relative extrema can only occur at critical points. Okay, we were going to save this to tomorrow, but you guys did so well on that, we're going to go ahead and get started on it today. Okay, so the next thing we want to do is we want to look at a derivative and find critical points, and then we want to decide if those critical points are relative extreme. Okay, what are the two types of relative extrema? What did Alexis say? Maximum and a minimum. Okay, so let's start with the critical points. Critical points occur when the derivative is 0 or undefined. So which one of these graphs is my derivative? The dashed is. I'm gonna go ahead and make it red. That way it's easier to see. All right. So raise your hand if you can identify critical points for me. All right, Ethan, what do you got?
X when the derivative is 0.
Okay, so give me some locations. I need to know where.
Oh, C.
C.
And then I guess H.
H.
And then C would be the minimum, and then H is the.
Hang on. There's one more.
Oh, F.
F. All right. So I have 3 critical points on this graph. Okay? Because what's going on with the derivative at those 3 spots? It's equal to 0. So my derivative is equal to 0 at this. Okay? Now, relative extrema, okay, when we talk about relative extrema, that means we're talking about the function that's above the derivative. Okay? So that means we're talking about the solid line. So I want to know what are my relative extrema of that. Okay? And we're going to use our derivative to verify it. And then we're going to match it up to see that's exactly what's happening. Alexis?
C, F, and H. No. C and F, not F. C and H.
C and H. What's going on at C and H? What are you telling me about C and H?
C is the minimum,
C is the minimum.
and H is the maximum.
H is the maximum. Okay.
And on F, I think it's because the slope is 0.
Okay. So F is not going to be an extrema, but I do agree that C and H. So C is definitely a minimum, and H is a maximum. Now, how do you know that one's a minimum, that C is a minimum and H is a maximum?
Well, C is obviously a valley.
All right.
And
So that's what I was wondering if that's how you were doing it. You're looking at the graph of the solid line. You're looking at the graph of the solid line to determine whether or not it's a maximum or minimum. I want to look at the graph of the red line to determine whether or not there's a maximum or minimum of the solid line. Okay, so definitely there is a minimum here. Okay, but I need to look at what's going on here to justify why there's a minimum here. Alexis?
Is it because it crossed the x-axis?
It's close. You got to be more specific than that.
Because it was negative first.
Because it's changing from
Positive.
negative to
Positive.
positive. Okay? And if my derivative is negative, then that means my function's doing what?
It's decreasing.
Decreasing. And if my derivative is positive, that means my function's doing what? Increasing. So when my function changes from decreasing to increasing, what do I have? I have a valley, which means I have a minimum. Or whenever my derivative changes from being negative to being positive, that means I have a minimum. Okay? So what's going on here with my derivative? It's changing from positive to negative, which means my function's changing from increasing to decreasing, which means I have a maximum. What is my derivative not doing here? It's not changing signs. So if I don't change signs, then that means I can't have a what? I can't have a relative extrema. I only have a relative extrema when I'm changing signs. Okay, so as you see, critical point, and it's a minimum. Okay, just like we said, it changes from negative to positive. Critical point, but it doesn't change, which means I don't have a max or min. Okay, critical point, it changes signs. It changed from positive to negative, which means I have a maximum. Okay, so let's go back. Let's go back up. And let's look at that first graph. Okay, and again, we're going to ignore what it says. Okay, and we're going to say, again, we're going to say this is f prime. Okay, so I want you to do two things for me. I want you to identify where the critical points are, and then determine whether or not those critical points are relative extrema or if they're not, and justify that point. So I'm going to give you a couple minutes to do that, and then we'll come back and look at it. So tell me where the critical points are, and then tell me whether or not those critical points are maxes or mins, or neither. And make sure you can justify it. How do we justify max?
Positive, negative.
My derivative changes from positive to negative. How do I justify minimum? Derivative changes from negative to positive. And if there's no extrema, that means my derivative is not changing sign. All right, Jordan, critical points.
B, D, and F.
Okay, how do you know those are critical points?
Because they're 0.
What's 0? What function are we looking at?
F prime.
We're looking at f prime. So these are critical points because f prime is 0. Okay, very good. All right, Deborah, what is B? Max, min, or neither?
It is a minimum, right?
Minimum. Why?
Because it's going from a negative to a
All right,
positive.
you said a bad word. You said it.
The derivatives.
What derivative are we looking at?
F prime.
All right, so because f prime does what?
Goes from a negative value to a positive
All
value.
right, so we're going to say changes from negative to positive. Very good. All right, Wilson, what's going on at D? Min, max, or neither?
D is the max because f prime changes from negative to positive.
Changes from what?
I mean positive to negative.
All right. Shirley, what's going on at F?
It's a minimum
It's a minimum
because f prime is changing from a negative to a positive.
because f prime is changing from negative to positive. Now, notice I had two minimums, correct? How many times did I need to write the justification? Once. Okay, so if I'm going to identify two things as being a minimum, then my justification is going to be the same for both of them. Okay, it's always going to be negative to positive. Okay, and maximum from positive to negative. Okay, so anytime you tell me something is a maximum or a minimum, you automatically already know what? How to justify it, correct? So how are we going to justify a relative maximum?
Positive.
Derivative must change from positive to negative. We're going to say we have a minimum because the derivative changes from negative to positive. So if you're going to tell me something's a maximum, then you already know what the justification is. If you're going to tell me something's a minimum, then you already know what the justification is. Okay? How you feel about that? Pretty good? All right, so today, what did we learn how to do today?
See if it's increasing or decreasing.
Determine whether or not a function is increasing or decreasing. Ethan, how do we do that?
See if the derivative is positive or negative.
Derivative is positive or negative. So if the derivative is positive, then that means the function is
Increasing.
increasing. If the derivative is negative, then that means the function is
Decreasing.
decreasing. Okay, what else we learn how to find? Critical points. Okay, how do we find critical points? What's going on?
Derivative is 0 or undefined.
Derivative is 0 or undefined, and we'll get to an undefined example tomorrow. Okay, and then we determine whether or not those critical points are relative extrema. So we've got a relative max if the derivative changes from positive to negative. We have a relative min if the derivative changes from
Negative.
negative to positive, and we have neither if the derivative
Doesn't change
doesn't
sign.
switch signs. Awesome stuff. You guys did good.